On this page, we look at quadratic functions or degree 2 equations and their applications. We first start out by considering the x-intercepts of a quadratic function. Given a function f of x, to find the x-intercepts, we set f of x equal to 0. F of x, remember, is another name for y, and then solve for x. Each such value of x is a 0 of the function. Sometimes in the directions they'll say find the zeros of the function, and they're just looking for the x-intercepts. The other names for them might be solutions or roots. As the next bullet indicates, the solutions to the resulting equation ax squared plus bx plus c equals 0 are called the roots of the equation. We have two main methods for solving a quadratic equation. We can either factor or use the quadratic formula. When we factor, we consider using the zero product property. And that property says for any two numbers, a and b, if their product, a times b equals 0, then either a has to be 0 or b has to be 0, or potentially both. Example 32, we're going to use that property to find the x-intercepts or the zeros of the function. We're also going to consider looking at the y-intercepts. So to start out with, let's take a look at the function m of x equals x squared minus 4x minus 45. To find a y-intercept, you let x equal 0 and then use arithmetic to find y. So what I mean by that is m of x is another name for y equals, substitute in zeros for x, and then use your calculator if you need to, but 0 minus 45 is just going to equal that negative 45, or the constant of that polynomial. So our y-intercept has the point when x is 0, y is negative 45. To find the x-intercept, or the zeros of the function, all right, same thing, x-intercept zeros, you let y equal 0. Now this one takes a little more algebra than arithmetic. So if I let y equal 0, or m of x in this case, I have 0 equals x squared minus 4x minus 45. To solve for x, we're going to factor this. So factoring involves reverse FOIL method here. So 0 equals, there's no term in common that I can factor out, so I'm going to go writing down my two sets of parentheses. You can think about what two terms multiply to x squared, and that would be x times x. Then you look at the last number and consider what multiplies to negative 45, but then what adds to negative 4. So you've got to come up with the right combination there. So for negative 45, I'm going to consider negative 9 and a positive 5. Negative 9 times positive 5 is negative 45. Negative 9 plus 5 also gives me negative 4. So in parentheses, I'm going to write in x minus 9, x plus 5. You can always fully FOIL this out and make sure that you get x squared minus 4x minus 45. In this next step, we're going to use the zero product property that says if I'm multiplying two terms together, one of those terms, or at least one of them, has to equal 0. So I'm going to set each factor equal to 0 and then solve for x. So x equals 9, or x could be the number negative 5. So I have two x-intercepts, one at when x is 9, y is 0, because we let y equal 0 here at the beginning. The other one is when x is negative 5, y is 0. So for letter B, same idea. We want to find the y-intercept and the zeros. So for the y-intercept, I let x equal 0. All right, so I'm going to have y equals, and then 2x squared plus 5x minus 12. Everywhere there's an x, you're going to substitute in a 0. So 2 times 0 squared plus 5 times 0 minus 12 is just going to give you a negative 12 result. So the coordinate is x part is 0, the y part of that point, negative 12. To find the x-intercepts, all right, we're going to let y equal 0. All right, so if I let y equal 0, I have 2x squared plus 5x minus 12. Now this one's a little more complicated in trying to solve for x because we have the number 2 in front of that x squared term. Our a is 2. So I'm going to go back and do a little of the factoring that I showed earlier. I'm going to do the multiply 2 times negative 12. Bring down the x squared, bring down the 5x. 2 times negative 12, negative 24. I'm going to remember, though, that I multiplied by 2, so eventually I'm going to have to divide off by 2 to balance it out. 0 equals, write down my 2 sets of parentheses. Now the factoring is going to go a little easier. X times x is x squared. What multiplies to negative 24 but then adds to positive 5. So I'm thinking an 8, 3 combination, a positive 8, negative 3, positive 8 plus negative 3 gives me positive 5. And put those two numbers in, a positive 8 and a negative 3. Now the thing is, though, remember, you multiplied by 2, so you've got to go back through and divide by 2 to balance this out. Reduce down any fraction that you can. So 8 halves is 4. If the fraction, like 3 halves, doesn't reduce, then we pull the denominator up in front of the x. We'll call it 2x minus 3. If I FOIL this out, I'm going to get the 2x squared. I have a minus 3x plus 8x, which is the plus 5x, and then a positive 4 times negative 3 does give me back negative 12. Set each factor equal to 0. I get x equals negative 4, or 2x minus 3 equals 0. 2x equals 3, x equals 3 halves. So I have two x-intercepts, one at negative 4, 0, and the other one at 3 halves 0. The past two examples have had 3 terms in them. Letter C only has 2 terms in it, so we're going to take a look at this and maybe solve it out slightly differently here. We're still going to find the y-intercept first, and again, that entails arithmetic. We let x equal 0, so y equals, we have originally 4x squared minus 36. So substitute in your 0 for x, and 4 times 0 squared minus 36 is equal to negative 36. So we have a y-intercept at 0, negative 36. For the x-intercept, I'm going to let y equal 0. So my p of x is the output, the y equals 0, and 0 equals 4x squared minus 36. My goal is to solve for x, and in this problem there's only one term that has an x in it. Whereas in our previous 2 examples we had 2 terms with x's in it. So we had to do the factoring. This one I can isolate the x squared though by adding 36 to both sides. So I have 36 equals 4x squared. divide both sides by 4 to get the x squared by itself. 36/4 is 9. And then take the square root to both sides. That'll get rid of the square on the right-hand side. Now when you put in a square root, you also have to include the plus or minus symbol for the two answers because it's a quadratic. So I have x equals plus or minus the square root of 9 is 3. You could have also gotten this answer, these answers, by factoring. That would have worked as well. But I have one point as 3, 0, the other point negative 3, 0 for my x-intercepts.